Hey everybody, we're going to go ahead and get started talking about cooling systems, the importance of them and how they work. So let me go ahead and get us in the share mode here. So we'll start off with some basics and then we'll work our way around. Uh, and one thing I wanted to, to say, a lot of this may sound like it's very basic. This is how the program goes. We have to cover a lot of different aspects of the automobile when it comes into, when we're talking about the kind of stuttered a little bit there, when we're talking about smog and how it's produced and like that. So we have to cover some of the basics. When you get into level 2 class, we'll start talking about the regulations, and that's going to be pretty deep. So let's go ahead and get started. You should be seeing an actual picture right there, I should say a PowerPoint beginning here. So cooling systems have been around for many, many years. And I just want to say that, or, even back when, then one of the things that we need to take in consideration is that, if you look at a typical four-cylinder vehicle, kind of cruising down 50 miles an hour down a, freeway, hopefully not down a road, side road or anything like that, but it can produce 4,000, controlled explosions per minute inside the engine. This it obviously produces a lot of heat. If not controlled, it could actually destroy that engine in a matter of minutes. It'd be just like meltdown city. And controlling these temperatures is a job of the cooling system. A modern cooling system has really not changed that much through the years from back when we had a Model T. We've added more stuff on it. We've gotten better at controlling the heat, but I do want to say this right at the get-go: the cooling system is just not, and I think that is a bad word for it. When anybody hears the word cooling system, they think, hey, it cools it down, and that's all it does. It actually maintains heat, and this is going to be very important when we start getting later in this actual module, because we are going to try to maintain heat. So it's actually maintaining the heat to a specific temperature, and you'll understand the importance as we go along here. So let's go ahead and, how does the cooling system work? We'll start off with, there are two types of cooling systems. There's one, which you're probably most accustomed to, is a liquid cooling system. But we did, and it's not as popular, more so in airplanes, but not in the automobile, is we did have some air-cooled systems. And these air-cooled systems, kind of when I'm thinking about the most common ones are like Volkswagen had their little Beetle model, even some of their vans had an air-cooled system on them. There was a Chevy Corvair that was kind of popular. Some of your Porsche models, they actually had an air-cooled system, and there's other ones out there. Many of the motorcycles out there, actually have the air-cooled system, but the cooling system, is actually, to control it, the air-cooled system wasn't that great at it. Yeah, of course it would dissipate heat, but we could not control a temperature very well, especially when people start taking the air ducting pieces off and stuff like that too. So what we do with the coolant type, cooling system with a liquid, or what we call a coolant system, we use different parts in it, and we're going to break those down as we go along. but we're going to actually circulate coolant through, which is a mixture of, and I'll get deeper into coolant in the next video, but we're just talking about the cooling system right now. But it's a mixture that actually takes and absorbs heat and actually can dissipate heat at the same, in the same part. So let's break it down here. So we have, a basic cooling system right here. Here is, what you might find on the basic type, and there'll be variations. Let's put it that way. We can have different ways of putting things together, and I'll break those down as we go along. But I just wanted to point out, well, of course, we've got, the basics of it. Of course, the radiator up front. We'll talk more about the importance of him in a little bit. Then we've got some connecting hoses going into and then again, I want to make it clear that this is just a generic type of engine, and there could be some variations, and I'll try to break those down as we go along. So one of the most important guys here is the thermostat, and I do remember back in when I started out, if a car overheated, a lot of people just take the thermostat out. That is not a great idea, because remember, we're trying to maintain heat. We're not trying to take and let's put it this way. We're not trying to just cool things down, because if you think about it, and I'll talk about this in a little bit, we want to control that heat. We want to make sure the heat stays at a certain temperature, because that will help the combustion process and get rid of those nasty type gases that we want to control. There's other things, and we're going to break that down in this class too, how these controls work as we go along. So, one of the things that we want to remember is that we are taking a fluid, which are coolant, going through the actual cooling system. And to do that, if we just keep on circulating all the time, it just keeps on going and going on. A couple things happen here. We're not going to get up to operating temperature as quickly as possible. And that's a key word you need to think about. And we also have the other edge of the sword here. See, we're going to take a longer time to get my car warmed up. Boom, boom, boom. It's just going to just circulate and circulate and circulate and circulate and circulate. And then if we drive for a long period of time, there's another side of that too. If we drive for a long period of time, say we're flying down the freeway, we're going, let's say, up to Vegas or something like that, we have a possibility of overheating too. So because that coolant is just circulating and it's just taking all the heat, and we really don't have a lot of time for that radiator to dissipate the heat. And I'm going to bring up the radiator in just a little bit here. So that circulation needs to be shut down for a period of time. And that's where the importance of the thermostat. That thermostat is kind of like the little control that stops the coolant for a period of time. And when it stops for that period of time, it actually allows time in the radiator to cool down a certain portion of the coolant. And that allows it to dissipate the heat. Now, when we get the engine temperature up to the right temperature, then we're going to open up that thermostat again, and we're going to change a certain portion of that actual coolant and cause it to allow, again, to start heating up in the back, and we're going to start cooling down up in the radiator. So in the engine block, it's starting to absorb some of that heat, and then at the radiator, it's going to cause it to actually cool that section of it out too. So it's a great deal, and it keeps it at a constant temperature. It helps in the morning to allow it to warm up and get it operating temperature a lot faster. and also helps later on to cool down a section of that coolant to make it to where we can continue to keep at a constant temperature. And this is just showing, again, this is not saying every engine circulates this way. We do have engines that circulate differently. And this is just one example. So we're taking, and this is showing a downflow radiator, which is not as common as the cross flow radiators that we have on more modern cars. Now, this is just showing an example. So I have coolant coming from that thermostat we just talked about, coming up through the upper radiator hose. You'll notice this radiator hose is rubber, and that allows for flexibility. Or if it was a solid mount, then we could actually start breaking pieces apart. So this actually dumps down to the radiator, allows it time to actually, because the radiator has a lot of fins to it. Now I'm going to show you what a radiator looks like and what I'm talking about in just a minute here. But I just want to concentrate on the flow, or the actually circulation of the coolant. So it drops down, goes through, and it goes into the water pump. We'll talk about the importance of that in just a minute here. And then it allows it to flow through the actual engine and the cylinder heads. And then it's going to actually come back in and go up to the thermostat and do this whole thing again. The other portion it does too is it actually takes and pushes or circulates, I shouldn't say circulates coolant through a heater core. This is for, when it gets really, like it really gets cold in California, but when it gets cooler and we want to get a little bit of heat inside the actual passenger compartment, then we can actually circulate some of that coolant to actually help warm up the passenger compartment too. So this is just, talking about circulation, and this is really important. Now, one of the things I want to add to this too, it's important that you have the correct amount of coolant in your actual engine through the whole cooling system itself. So antifreeze, now this is, now understand that a coolant that actually is in the system, if it's left uncapped, and we're going to talk about radiator cooling, actually radiator caps in just a minute here, but the coolant actually can boil if it's not controlled. So let me talk about coolant first. So coolant is usually, and can be different, is about 50% coolant and 50%. I don't want to say water, because if we use this tap water, this is actually going to cause more problems. Now, coolant has many properties. One, it has a lubricant in it. It has a actual rust, corrosion. It has a lot of properties, and it really is important that, please watch my video on coolant, because this is going to be a little bit more important. But we, in this program, we really talk about the coolant system, and we don't really go too deep into the coolant itself. But it helps, with the water pump. It helps with actually any kind of corrosion that can happen, and this is where it's important that the coolant be changed out in a specific amount of time. Look at your owner's manual and how that lays out too. But a couple things. One, the coolant is, and I want to make this very clear. I've seen some crazy things happen, but it is sweet to the taste. And this is because I had an actual radiator hose blow up in my face one time. And I got a little bit, and it was very sweet. But you don't want to ingest this, because it's very poisonous. And it's poisonous to humans. It's poisonous to animals, and you want to dispose it properly. If you just pour it out down the drain, that's illegal. and it has to be disposed properly. Don't just pour it out in the garden or anything like that too, or in the gutters or anything like that too. So you want to make sure and that you now. One of the properties of coolant is ethylene glycol. This is really, and ethylene glycol is probably one of the most common in it. It has the ability, again, like I'm going back to safety on this, but if you ingest it, it can actually cause the kidneys to fail, and it will actually lead to retinal type failures and death like that. So please do not drink this stuff. It's there for a reason, and it's not not to be ingested. I just want to make that clear. Okay, so radiators, this is another part. This is a picture of a radiator. This is just a common type. Yours might be a little bit different shaped. Please don't use this as the tell-all. Now this is actually a cross flow. The last one I showed was a downflow. This is a cross flow. So it would actually flow across, and that's why it's called a cross flow, all the way down to the bottom. What's important in the radiator is that it actually can, I put it this way, two common types of materials that use is either aluminum or a copper brass type one. Now, they have a lot of fins across them. These fins need to be taken care of very, very nicely. If they get damaged, they do not dissipate the heat the way they were intended to. Now, you'll see on the top here, these little tube affairs. Now, these are very, very small, and this is why it's really important that you want to keep the cooling system clean by changing it out, flushing it out, and make sure you dispose of the coolant properly. But you'll see these fin affairs right here. These fins, they separate, and these can actually help dissipate heat. And that's what's really important, that you take care of that. And there'll be more fins on the outside too. If you look at the way the radiator is laid out, and you see this, all this tubing is dropping down. You know, it might be kind of hard for you to see, but the tubing drops down, and these fins going down this way help separate the tubes, and also they're in between, and they cause a you know, kind of a temperature kind of migrate, and then actually it allows it to actually blow air across them and dissipate the heat. Now, how do we actually get the heat away? So there's a few different ways. One, if we're driving down the freeway, it's not a big deal because the air is flowing across the radiator. It's going to cause that exchange of heat. Now, the other way we do is we have radiator fans. Now, there are a few different types of radiator fans, but the most common nowadays is an electric fan. We can actually turn them on and turn them off as the temperature rises. And this is really kind of important, especially when you start looking at cars with air conditioning too. We want to make sure the with the air conditioning on, we have the fans controlled on. So this is one style of radiator fan right here. This is, like I said before, it has a set of blades inside here. These blades actually actually pull the heat across. Electric fans are probably the most common, but there is some old, and unfortunately, it looks like I didn't put it in this presentation, but I do have it in your reading, an old mechanical type fan. These old mechanical type fans are not as efficient, and plus the old mechanical fans actually take a certain amount of horsepower off the engine too. That's the beauty of the electric fans. I just like to picture that doggy. Now, radiator caps, this is really important, and a little bit of safety on this too. Radiator caps are allowing the coolant to be under pressure. And why do we put under pressure? If we allow the regular boiling point, it will actually boil over. If I put a pressure cap on, I can raise the boiling point. It sounds kind of weird, but I can raise the boiling point. If you've ever worked with a pressure cooker, that's how they work. They can actually raise the boiling point. But the one thing I wanted you to be cautious of is taking that cap off when it's actually, the engine is full operating temperature, because there's such amount of pressure. We got, 16-pound caps on the cars, and if you open that up, it's going to be in your face, and then we can have first, second, third degree burns. So best off, always take that pressure cap off when the engine is cool. I of course, done stupid things in my time too, but I've learned, even with a rag, it will go all over the place. So you want to be very cautious when taking the cap off. But these caps are actually programmed. Well, I shouldn't say programmed, because that sounds like they're actually on a computer or anything like that. But they actually have a certain amount of pressure to actually build up that boiling point. So we want to make sure that that pressure cap is good too. In my actual reading for you, it actually talks more about how that pressure cap works. It has a pressure side and it has a vacuum side, and they are pretty cheap. Let's put it that way. If you start getting some strange symptoms where it's just pushing out through the reservoir, a pressure cap's probably in sad shape. If it's not pulling the fluid back over into the actual engine when it's cooling off, the vacuum side is probably not working. So again, the pressure cap has two sides to it. One, to allow as fluid expands to go into the reservoir tank, and then it also has the vacuum side. So when the engine cools off, it can pull that fluid back, that coolant back in to the actual radiator. So you still have that controlled and a perfect amount of coolant in your vehicle. Now your reservoir can, this is what I was just talking a little bit about too, and this is the best place to check cooling system. Your coolant, I should put it that way. Now, of course, there can be some strange things with the cap as we go along, but you'll notice right here is the excuse me, the actual reservoir tank. Now this one actually has a level where you would look to see what the level should be at. If it's cooled down and the level is right here. So say first thing in the morning you get up and you go, hey, I'm gonna go check the coolant. I can actually see right here that this one must be warmed up right now. But if I'm right here in the midst of all this, the low and not the full, then I'm pretty good, because remember, the coolant is going to expand. So we expect, as the temperature of the engine warms up, it's going to actually expand, and we're going to actually see it go up to the full mark. So this is where I would actually fill and actually check the coolant. And water pumps, the water pumps are, it seemed like a simple device, but they do a lot for us. They're the one pieces that are actually going to be circulating the water through. Now they have a set of fins. I've got another picture for you in just a little bit here, but they are, responsible for circulating. Now I didn't put up here, but there are a few electric water pumps on some of them, in some of the models out there too, which is is another way of doing it. So here I have a water pump. This is going to be belt driven. They don't have the actual the pulley on it and the belt attached to it, but you can actually see it bolts up. And this one is going to actually have a mechanical fan on this one, unless it's been converted. So the water pump, it'll have, it has the housing. You see the impeller right here. This is actually what actually helps circulate it. It's made in a certain way, and depending on what kind of system you have, it's going to be a conventional type flow or a reverse type flow water pump. Some, and it's not very common, but I know of a few Nissans that actually had where you could bolt up either one, and if you have a car that's continuing overheating, that's, you know, we may have the wrong water pump on it. Talk to your customer. They will tell you, they'll let you know if it's been changed in a recent amount of time. So this is a either an aluminum, or they can be a cast type housing on them too. But this guy, he's the guy who's responsible for circulating the coolant around. Now, the thermostats, like I said before, they're a simple device, but they actually have, they really do a lot. And you'll see this little guy on the bottom here. This is part of the bypass system on it. So as the engine, because they don't want to just block everything off so it can't circulate anymore, we want to keep on circulating, but we're going to circulate it back through an actual bypass valve system like that. So here's what I'm talking about right here. So here's the bypass section here. So as we're just circulating through, we're going to actually open that up and allow it to bypass until we get up to the operating temperature. And then the thermostat is going to allow us to go out to the radiator. Now, what happens when the thermostat valve is removed? And I kind of touched that a little bit, and I wanted to make sure that, if you do, you could have potential problems in, it seems like a quick fix, but it's really not a quick fix. You want to, because some of these thermostat are part of a housing now, and they're quite expensive. So you don't want to just, you can't even take the thermostat out of them anymore. You want to make sure that you, and you want to make sure that you have a thermostat in place. And if you have a problem, again, this is another fairly inexpensive piece, unless you have ones that are built into the thermostat housing. And you can change them out usually in not too much time. If you have some vehicles, some of the thermostats are down below, and it's really sometimes a kind of a pain to change out. But again, this guy is very important on this thing. So like I said before about the bypass, I just wanted to show you again how this is actually put up. So the other thing, and I hate the word freeze plug, they're actually a casting plug. When the engine is actually manufactured, they have these casting plugs. These casting plugs are there's little passages, the little coolant passages that circulate coolant around the cylinders themselves, the cylinder head, and they are the ones that actually allow it to absorb heat and take the heat away. And that's the beauty of the coolant. The ethylene glycol is very good about capturing heat. And this is one thing I didn't say a minute ago, but I want to make it sure you're clear on this. But you want to put the specific amount of coolant to the specific amount of actual, I hate to say water, but the water, you want to have it, that blend that the manufacturer has. And you want to do the 50-50 in most cars, and some cars have an actual 60-40. But why I bring that up is this passages, if we do not, and we have the passages plugged or the passages are not there, then we can't absorb the coolant, they can't absorb heat. Now, the way the engine's made is these use these casting plugs as to shake the sand out of the block. Yes, we can go this way, but we want to be able to take all the casting sand that they use and get it out of the system itself. Now, you don't see it as often as when I was starting on field, but these and a lot of it has to do with neglect. If you have these, can actually they were all metal instead of these brass ones, and they would actually rust out, and we would have to change them out. And these were kind of fun to do on some vehicles. But you have casting these freeze plugs that they call them, or casting plugs. Another picture coming up right now. Another one about, you know, the freeze plugs. And depending on what kind of motor you could have 3 or 4 on the one side. And these were very, very common. They are very, very common. Now, cylinder heads actually are not perfect machined. Also, the casting blocks are not perfect, but very close. But we have head gaskets. These head gaskets are to take up that little bit of space that, and we sandwich the cylinder head to the block itself. And again, when you get into your engine classes, they go deeper into this, but these cylinder head gaskets are very important when it comes to actually controlling and making sure combustion stays in one spot. These cylinder blocks and cylinder heads, again, like I said earlier, they have little passages that actually have coolant going up and through, like here. And this actually allows the block to stay fairly up at operating temperature. Now, these actually have passages to allow that to happen. And these gaskets, and it's important to remember that some vehicles, if they're like the V models, V-shaped models, they actually can have they actually can be put on backwards. And what I mean by that is some of the gaskets, if you look at this one right here, this guy is forward, and if you put him upside down backwards, and they all mount up, but this will block off this actually part where the coolant can't go through itself too. So you want to make sure they're clocked the right way, they're installed the right way, so you don't have these actual problems. So this is just one thing I've seen along the way like that. So head gaskets, usually fail, when the engine overheats. You can have warpages of a cylinder head. You can have, and I've seen this happen, cracking of the cylinder heads, cracking is the actual block itself. It depends on how hot it gets. But one of the how to identify this? Well, there's different ways of doing it. There's a HC test, which you actually use in actual infrared, not infrared, actually an actual infrared analyzer, which is going to be your bar 97 machine. And there's a specific procedure to actually check for hydrocarbons in the coolant. And we'll talk more about this in class when we get into the testing mode. But hydrocarbons should not be in the anywhere close to the coolant like that. There should be a total separation. That's what the head gasket is all about. And also there's a chemical test which checks for hydrocarbons in the cooling system. I prefer to do that one because you don't damage your infrared machine like you would if you were doing it and you did it incorrectly. So just a little example of what a broken head gasket, okay? You can actually identify this by a simple compression test, and you'll get these two cylinders that have almost the same compression all the time, like that. So head gaskets replacement, you begins with the diagnosis and that they failed. You don't want to just change them out all the time. This is one of the things, like I said earlier, there is a procedure for checking and knowing how and how. Now, you can also have coolant in the cylinders. Sometimes there's a lot, and if you have a lot of coolant in the cylinders, they can hydrostatic lock. And that means that there's, as we know with engines, that there is a compression. In other words, a piston jumps up, or travels up, and then we compress a certain amount of oxygen and fuel, or air and fuel. Now this gases will contract, okay, or where you have fluids, they will not. They will be like a block wall, and if you have enough in there, they'll lock up the motor. They'll start bending rods and stuff like that in the engine. So just a kind of a picture of a head gasket and showing you the placement of it. So we have the cylinder head, the head gasket, and the engine block. All right, a little bit of comfort here. So this is for, passenger yourself. So you have a heater core that goes inside the actual vehicle compartment. And this will allow, as you need, if it gets too cold outside, you can actually turn this on, and we're going to flow coolant through here. So one of the things I always look for is any kind of leaks that could happen. Remember, this is inside. So if you start getting some green stuff coming out of the drain, the evaporative drain, it's going to be green, red, depending on the color of the coolant. It's and a heater core starting to leak. Hopefully you get it before it leaks really, really bad. And another diagram here showing hoses. So all these pieces are rubber because the engine is not solidly mount. We allow a little bit of movement, and that little bit of movement that we use rubber hoses to accommodate that. And we do that also in our air conditioning too. We have rubber hoses also in that part too. Now, talking about hoses, this is not uncommon. This is what got me one time. And the actual hose actually expanded, and this is what I was inspecting the vehicle, and I was looking for a concern about a customer. This had nothing to do with the hose. It was looking for a running concern, and this hose actually, while I was testing it, I seen it, and that one time you go, holy crap, and you kind of try to move out of the way, boom, right up in my face. So they rubber hoses should be inspected. They should be changed out in a regular basis. Now, depending on the manufacturer, is what they're going to recommend for hose replacement. If you can see any kind of things like this ballooning hose here, definitely and you don't want to go by what the manufacturer says. You want to do it now. Other things too is the internal part of the rubber hose can actually start breaking down, and it's not just total rubber. There's some fabric inside of it too. And if you start, and this is actually what happened with this one, and if you start kind of, what I normally do is I kind of squeeze the hose when it's cold, and if I feel any kind of crunching or any kind of like thing like that, that's a sign that it needs to be replaced. It could be a sign that the actual fabric inside is breaking down like that. That's one of the things I do. I'm also looking at the shape of the hose as we go along. You'll start seeing some telltale signs, any kind of leakage around the clamps and stuff like that too. And then it can, of course, the time. So I wanted to finish this off with just remember to check the proper coolant level. And this goes to when you're before you're testing and before you're driving the car. You don't want to damage a customer's car. When you start doing some tests, you want to make sure it has full coolant. And my other video is going to be on the engine oil, but you want to make sure your fluids are full. So one thing is to make sure it's properly cooled, and also, and I've seen some strange things happen, folks. You want to make sure you're looking at the temperature gauges. You want to look at your gauges to make sure they're correct. If you get a situation where the gauge is not even operating, you need to, for sure the temperature is rising just by checking the hood open and looking at and feeling same things, maybe taking in your little infrared gun and going through and checking temperatures and stuff like that. But these, you want to monitor your actual gauges. I have the one up here is actually showing it's not even coming online. So we actually have a problem here because I already see this guy's, doing pretty good. Then I also see another problem here is creeping up to the hot level. And I want to be, it's not really bad yet, but if it's mid-range, you want to monitor it being too cold or too hot. So this is just an example here too. So it looks like this one's having some really fun things on. Are they really doing 175 miles an hour? And look at the RPM. This motor's getting ready to explode. So way up there. I would really be concerned about a gauge problem on this problem too. All right, folks. Hopefully this is beneficial. If you have any thoughts or anything of that, please comment down below, or you can reach me with my email address, or you have my voicemail too. So please let me know what you think, and I will be talking to you soon on the next video. Take care now. Bye for now.